Hello, and welcome back. So we're in V1, okay? So first, the previous tutorial, quartz mesh, you get an idea how things work. So now let's do a finer mesh. So open the parallel, so see that here we have short description, quartz. Let's use fine mesh, okay? So here we're reading this dictionary, the rest, nothing changed. Let's see what happens here, and we're going to see now. Just by knowing your geometry, precisely what you need to modify, how to control keywords, you will get an idea that you can have a lot of control. You can generate good meshes in Snappy. So basically here we're still reading saying geometry is nothing new, but now we get access to the small face. So recall that in the previous case we didn't refine there. Now let's get that face to add some refinement. Then here we have this, I call it kill junction, 1, 2, kill. So basically we're accessing now these surfaces and so on. Okay, so here you have the names, the STL. Remember that you have a README file there, which description what is each one. So now here we access everything there to add region refinement and these two leading edge. Okay, nothing changed. Be careful here that now I think I still have an increase. Still is going to work. Probably it's going to give you a warning, but at this point maybe it's a good idea to increase this value, but doesn't matter, it will work. So now feature edges. So now look at previous case, we didn't capture the complete edge. So coming back to this one, we didn't capture that complete edge. So now that we access all these faces, we're going to capture all those edges. Probably too many faces, but it's up to you, okay? The complexity is up to you. Honestly, I have to say something that I will check in the source code. You cannot use wildcards. Here it would be great if you can do something like that to select all. You cannot use, or I didn't find the wildcards. It's a suggestion to the developers. I will check that in any case again. But yeah, imagine that if you have 100 edges, yeah, you need to put that 100 times. But remember that you can modify, you can manipulate this object, this image, because then you can merge the OBJ, you can merge those files and then save a single one. So it's not a big of an issue, but if you could use wildcards would be nice. We have a single geometry for 4 in this value here is okay, and then regions. But now look at that in region, and this is to stress again now, because recall that we're reading surfaces here, and you might think, oh, as I'm reading this surface, I will access that surface refinement here. No, if you are reading a different STL surface, that refinement you need to apply it in refinement region. In theory, you can use it in refinement surfaces, but you are not going to get nice results. Okay, you're going to get some imperfections, some artifacts there that they are not good, and we have seen that. Okay, so you can do that here in refinement surfaces if you prepare your STL or OBJ with Mesh Mixer or whatever tool, and you do the regions inside the STL. Okay, that we have it, and you can do it here. But honestly, I feel more comfortable doing everything here. So look at that, I'm accessing everything. And look at it now, kill, refinement 5, this distance, and so on. So now I start to add more refinement. Look at the leading edge. I added a refinement of 6. In the bulb that we have a lot of curvature at 6. And so on. The front face, the small face, look at that, we have 6. And that's all. The rest exactly the same. So let's run this case. So this will take longer, but honestly, it still is something affordable, something relative fast. So remember, adjust your script to read V1. Okay, so let it run. snappyHexMesh, pay attention to the messages so see that all this image, because from time to time you will have some warning and you can have an idea what is happening. Okay, so always take time and read those snappy that are interesting, very interesting. And as soon as you understand, know all these quality metrics and precisely, you will see that the influence of each quality metric will be or boundary layer, small faces, negative volumes, and all those messages you can see here. So let's wait for the final match. Okay, so we're back. We have a mesh. So you saw check everything, but look at that. Everything very smooth, small issues here. So this one, but it's being fixed by OpenFOAM with no problem. And okay, no objection. Look at that. This is fantastic mesh. And let's do the other step. Okay, let's generate also the boundary layer just to analyze everything. So let me be sure that this is okay. So this one will bum bum from this time 3. So if time 3 exists, erase and then do this. So this should work. I don't see any reason. And then it's doing the reconstruction. Just the okay, probably this was the issue, probably. Okay, let me comment that. Okay, mesh parallel add BL. So let's add the boundary layer. And this is an issue. Already see that was starting from time 1. I don't know why. And BL. Okay, so I have a problem. Okay, I need to redo the mesh. Sorry about this. So using the magic of video editing, we're going to skip this. But okay, there is a problem with this script that I will fix. Oh, let's wait for the mesh. Okay, so we have the mesh. Okay, this script I will fix it, but what we need to do is just this step. Okay, let's access this one, MPS now P minus para. Okay, so access in 3. I don't know why here is doing that. In any case, so probably I need to double check that one. So here, okay, look at that now. I know that, okay, here near wall, I am well above that limit. So it will work. We'll do some iterations and 90% of coverage. So this is quite good mesh. So let's go Paraphone built in. So you know now how to push the boundary layer, okay? I'm not going into details. This case, with a finer mesh, the surface refinement overall of 6, I managed to go to 10 to the minus 5, which is good enough, okay? Very good. And I think you can go even lower in the near wall distance, but you need very fine surface meshes, and it would be better in this case, instead of going up on the surface refinement, let me go here, of putting values of 8 or stuff like that. Okay, it is better to have a finer background mesh. So you can use the technique that I didn't do it here, but you can do it, you know how to do it, to add local refinement around the body, like we did in the case of the NACA airfoil. So you can get, with the same level of 4.4, you can get something much, much finer at the surface level. Okay, in any case, let's go here, let's open. And I am just interested in this one. We know that we have all refinement regions, everything exists there, so it shouldn't be any problem. So first step, remember we have all these steps, it is castellation. Castellation, you add all the refinement, and clearly here you start to see that by manipulating or using the individual surfaces. Look at that, we managed to capture everything. See here that you have the refinement in the leading edge, the refinement here in the bulb there. In the back, you have the refinement, a lot of refinement there. Okay. Then the front face also, you have some nice refinement, so you're going to capture things better. So already visually castellation, it is very promising. Next step, now we snap. Not bad. This is okay. Capture nicely curvature, much better curvature there. Now you start to see that you can have a lot of control. However, as I have been saying, and as I criticize a lot, here the aspect ratio to control the growth rate, you are forced to do it 2 to 1. There is no way to have a growth rate of 1.2 like in truly unstructured mesh. We have seen with Fluent. Later I will show you with some other tools that you can control that. Here is this 2-to-1 that is very problematic, okay? And all these quality metrics, I guess you get the idea that it gives you problems. So look at here, also nice refinement. The top also, let's look at the edges, and you will have these problems here. For me, I can live with no problem with those issues. I know that very likely boundary layer is going to give me problems there, okay, but it's not like it's going to destroy the entire solution. It's just those edges, but you can try to solve those issues. We talk about that you can increase the number of the feature, snap feature iteration. So now we move here. So try to increase this one double to 20 or 40, maximum 100, okay? And check might help you. I don't recall. I know I recall that it helped, but it's not 100% a solution, and it will increase a lot your computing time. So for me, I don't care much about that. Then we move to the last time. Okay, so it's 3. And in this one, we have access to this. And voila. And this is a very good coverage. No objection here. I have no problem. I know that that is a very small face. Here, the edges, okay, I know what is happening, but also it's not a complete collapsing. Instead, you have one layer there. Some faces, some points there that likely I know those points where I have the transition, the 2-to-1 transition that I criticize a lot, and clearly you can see here the faces and so on. Okay, some cases, look at that. This is a face, surface face that you have many edges, many sides there, and so on. So there you go. So nice mesh. And talking about the number of faces that you have, I want to also take your time and read now the check mesh file, because look at it here. You have elements with 18 faces. Sometimes you can see elements with 30 faces. That is a problem. Even OpenFOAM will handle, and any constructor solver will handle. Ideally, you should have all the polyhedrons about no 12, no, the dodecahedron structure, which would be the best one. But we start to get something like 18, 20, 24, 30 faces might be problematic. And likely some of the surface, so some of the points where you have those pinch points, or that the mesh collapse and so on, might be related to those elements with many faces. Okay, so at this point, I think we have covered a lot. The other thing that I would like to address is checkmesh. You know, it's very important we talk about checkmesh, but also uh, interrogate checkmesh, or give more verbosity to checkmesh. You know, so here you have this reference now, and probably this is something that we will cover with the when we add the rotating, but also in checkmesh you can tell to give you more information, all right? All geometry, all topology. So let's see what happens in this case if I use that action. MPI run P4. Okay, so we'll check topology, everything, and we'll give you more error. So here, so far we have seen the basic information. So see that now it's telling me, okay, well, that was the castellated, that one probably. Okay, so look at that. Now you have extra errors that you can very easily correlate with this quality. They are not critical, but look at that. Now you have pyramids there, 14 faces incorrectly oriented, which is not critical, okay, but it's directly correlated with some quality metrics, and we have seen in another video that you can erase those elements as well. So if you inspect, you will see where you have those elements, and for you it's okay. And a 51 elements out of what? How many cells do we have? Almost a million. So probably it is something acceptable. You can do it. Then here you have some concave. Probably these are not a big problem, but maybe also on the surface they can give you some issues now that this cell collapsing warped faces. So there are very specific metrics that can control that. So you can reduce the values, and probably you will see that these numbers will be lower. Okay, but here you can get more information. So also check that, give more verbosity to checkmesh. And to end, also remember, check your geometry. Surface, check, and let's see our geometry. Constant geometry. I think it was this one. It's the yes. And see that if I run a check there in my geometry, that and look at that, it's telling me a lot of stuff now. You have a very small faces and some illegal faces, dimensions, and some errors. So it might be also better to try to fix this error. I know these issues that I have here is that because the dimensions are very small now, so scaling will get improved. Also, if you pass in Mesh Mixer and use the inspector, it will fix some errors. But look at that, you have some errors there, below your mesh, you have your geometry, and probably these small issues can be reflected in whatever is happening in your mesh. So yeah, this is all for this iteration. Let's move to the next iteration that we have a much finer mesh. So see you in the next video.